Sorry for the slightly slow start. That was my fault for having the wrong time for this in my calendar, but I'm really glad to be presenting to you. I want to thank the team at RESNET for setting this up and for all of you for your interest and attendance today as we look at the second draft version of the RESNET Standard 1550. I'm going to start off the same way that I started off the last webinar on 1550 because I think it's important to sort of ground ourselves in, the reason that we're bothering to look at embodied carbon in new homes. And the prevailing reason is they make a really big difference to the climate. So based on initial studies that I've been involved with of measuring embodied carbon in about 1,000 new homes over about the last 5 years, we have found that a reasonable average right now for the emissions that come from making the materials that go into new homes, or at least those materials that we count in these studies, is about 63 pounds of CO2e per square foot of conditioned floor area in those homes. If we multiply that out by the somewhere just shy of 2 billion square feet of annual new home floor area that's constructed every year, that means that the materials that go into our new homes are responsible for about 53 million metric tons of emissions per year. And if you're like me, that probably sounds like a big number, but I didn't really know what it meant. So I went and compared it to the emissions from entire countries. So if we look here on the screen, Austria, Greece, Hungary, Norway, so all relatively populous and advanced economies, and making the emissions that come from making new homes in the United States is equivalent to all the emissions from their entire economies. So, the home building sector would sort of rank highly if it were a country in the world for its contribution to emissions. So clearly this is a lot of emissions, and we have sort of good reason to want to figure out how to measure it, and then once we've measured it, be able to reduce it. It's also important to remember that the embodied carbon emissions from building projects happen upfront. So it is all the emissions that happen from sort of harvesting raw materials, getting those raw materials to a factory and manufacturing them, or at least that's what we're looking at in this standard. And you can see that if we have about 55-ish tons of emissions per home, that all is in the atmosphere the day that the new homeowner moves into that home. Whereas the operational emissions are significant, but they grow in significance over time. So again, sort of taking some averages, in this case, from a forthcoming study in Massachusetts of 100 homes, we're kind of looking on average at about 18 years before the operational emissions catch up to the embodied emissions. So not only is the embodied emissions, a big number in total, but its impact on the climate is sort of, now and outweighs the operational emissions for quite some time. Now, obviously, this will vary based on the type of fuel being used in the building, its efficiency and stuff. We could have either more or less emissions happening from the operation side, but this is an average of the 100 homes that they looked at in Massachusetts. And so, 18 to 20 years is a pretty reasonable average. So not only are embodied carbon emissions big, but in terms of the overall carbon footprint of a building, they're going to dominate its carbon footprint for quite some time, a decade or two or more. So if we know that those emissions are big, and so we'd want to know how to measure them in order to reduce them, we also need a standard to do that, because the life cycle assessment procedures that you can use to measure embodied carbon can have a lot of different, as I've used the illustration here, boxes that you can look inside. And you only get comparable results if everybody is measuring the same things within the same box. And those boxes have a lot of variables, including the life cycle stages that you're considering, the boundary of the project, and which building products are you including. So obviously, if you change any of those variables and try to compare house A to house B, but any of those three variables have shifted, you're going to get an answer. The answer will be informative for that one building, but in order for us to be able to understand, what this looks like across the industry and what it looks like comparatively, we need a standard to tell us, what's in those boxes that we're going to be looking at. And then finally, why a RESNET standard for measuring embodied carbon? I think RESNET is a great place for this. Obviously, the HERS index is being used on a really large number of homes every year, and the RESNET has also added the HERS H2O index and the HERS carbon index. In particular, the carbon index that sort of uses the HERS rating to see how much energy is being used and then apply grid and fuel factors to that. That will enable a HERS rater to be able to look at both the embodied and operational piece. And because HERS raters are already modeling so many new homes, this standard is able to leverage the existing modeling data that those HERS raters are creating. So to do an energy model for a building, you're creating an area-based model, and to do an embodied carbon standard by our new RESNET 1550 standard, you're using those same area-based dimensions to get your material takeoffs. So there's some really great synergies here. I think, the key one being that being able to keep your eye on the operational emissions and the embodied emissions together, and to be able to see, if you're making a change in one, what does it look like for the other, and making sure that you're seeing a holistic picture. And I think doing 1550 within this sort of RESNET family of standards really helps, be able to track those things side by side. So in late 2023, the RESNET board founded the Standard Development Committee. Here's a list of the folks who were on it when it got going. So it's a consensus-based standard, like all RESNET standards are, and we've got great representation from stakeholders across the industry. To date, we have established the Standard Development Committee. The technical working group put about a year into making the draft that went public in 2025. We responded to well over 100 comments during that public comment period to create a second draft. And currently that second draft of the standard is out for a second round of public comment right now. I believe it's open until October 3rd. So if you see this webinar and feel like there's something you'd like to comment on, either positive or negative on the standard, you still have a couple days to do so. So just to give you a sense of what we set out to do with 1550, this is the purpose and scope statement. In this presentation, anything that is in red is language that's been modified since the first draft. So if you are familiar with the first draft, the things that I've highlighted throughout this presentation in red are to kind of draw your eye towards things that have been revised or changed or updated in the second draft. If you go online to visit the standard, as with all RESNET standards, it's currently all the changes are marked in red underlined text. So it's really easy to see what's changed between draft 1 and draft 2. Not much has really changed. We made a lot of changes for draft 2, but not a lot of big pivots or sort of major changes. Here in the purpose scope, just to be a bit more accurate, a few commenters suggested that we weren't just quantifying embodied carbon emissions, but we're also, it's a standard for how to verify and report on those as well. So that's the idea here. So unlike the carbon index or the HERS index, 1550 does not embed a rating system for embodied carbon, in large part because not enough people have measured embodied carbon to even know what a good, bad, or average score is. So this is really just a measurement and reporting standard. We want people to be able to do this. We want people to generate a lot of assessments, and that way we can start to understand what good, bad, or different sort of numbers are. And the second part here, the scope, is really just to let users know that the focus here is housing, residential buildings. In general, the typologies that are often constructed from wood frame construction. So, everything from single family homes up to small apartment buildings. Those are what we're looking at. Basically, if it's the kind of building that's being HERS rated, again, that's another one of those great links. HERS raters are looking at the kinds of buildings that we want to measure the embodied carbon of. So if you have been following the standard, you'll know that in the first draft, we put our focus on life cycle modules A1 to A3, or what's known as the product stage. So that's looking at the emissions that come from getting raw materials for products, getting those materials to a factory, and all the emissions associated with manufacturing, but stopping the assessment sort of at the factory gate. We decided not to include any of the other life cycle modules that you see on the screen here, not because we don't think they're important, but because especially for the residential sector, we just weren't finding enough data, enough verifiable data to know that we were giving people good numbers for all of those other life cycle stages. Now, if you look at the standard, the second draft, you'll see that we have, it looks like we've added a life cycle module, which I guess we have. A5.3 is in the construction phase. It's the quantification of product wastage that happens when you install a product. So manufacturers in their EPDs or by our default tables in the standard will sort of say, for my product, X amount is expected to be wasted on site. We had always included that in the standard. It was in the first draft, but some of the folks who were reviewing with deep experience in life cycle assessment sort of waved the flag and said, hey, that's actually not included in modules A1 to A3. That product waste rate lives in module A5.3. So all the way through, the language of the standard has been changed to not just A1 to A3, but A1 to A3 plus 5.3. So not really a change in what we had intended to measure. That was always in there, but just a more proper allocation of that in terms of life cycle modules. So here's a quick slide that quickly reviews how you do the math for embodied carbon, a sort of basic outline, which is for this standard, we develop material quantities, and in this case, those quantities come from dimensions. So one of the key tables in this standard is the table that gives the calculations for translating a certain amount of building area, whether that's floor area, wall area, window area, roof area, all of those basic dimensions into material quantities. And so there were some really helpful corrections from reviewers the first time around that helped us correct some of those factors to make that takeoff process more accurate. And then once you have material quantities, you have GWP, which is a global warming potential. That's the sort of emission factors that you would use, and you're basically multiplying, this much material by its GWP factor, and that gives you the amount of emissions that particular product is responsible for in the building, and then you sum all of the product's emissions, and then you get a whole building number. So in terms of the GWP factors, the hierarchy, the data hierarchy that we had created in the first draft has been both clarified and simplified this time around. It's always great. We had so many good commenters, really help us do that, clarify and simplify things. That was some really helpful input. Another change that we made, so by and large, the data, the GWP data that this standard rests on comes from environmental product declarations, which are sort of an ISO standardized way of measuring the GWP, plus a lot of other environmental impacts of building products. The first time around, we had, because there are going to be products out there right now that don't have a product-specific EPD, the first time around we had sort of included some factors for how to give a GWP for a product if it didn't have an EPD. And to sort of simplify and in some ways make these estimates conservative where the data doesn't exist, we've changed that from a factor that you would multiply the GWP of comparable products, and we've simplified it to just be you would use the highest GWP factor from a comparable product. So that sort of lends itself to being conservative, but doesn't apply sort of error factors like we were doing the first time around. Obviously, another important part of the standard is what are we counting? So which building products are included in the assessment and which ones are left out. Nothing has really changed in that we're really looking at the building. So some folks on our committee started calling this the drip line in approach, but really meaning that we're using the boundaries of the building itself as the boundary for the assessment. So obviously there's a big table that lists all the inclusions. There's a big table that lists some of the exclusions. The biggest clarification in this second draft around this the inclusions is that we clarified the language around inclusion of attached balconies, decks, and porches. It was a bit pointed out to us that it was a bit vague the first time around whether those were to be included or not. And so the biggest change there is that we made it a lot more clear that those elements of the building are intended to be included. Another change, again, not so much in the approach, but in the reporting, is the biogenic carbon. That's the carbon stored in materials that are based on on plant-based materials. So they have carbon in them that came out of the atmosphere. The first time around, we sort of asked that people report the GWP, so that you report the emissions, you report the biogenic carbon, you report those separately. So that's the same. We had also said it would be mandatory, or we made it a requirement to calculate the net of those. So, for any given product that has biogenic carbon, you'd take the emissions, you subtract the biogenic carbon, and you'd have a net number. You could also do that for the whole building. Those net calculations, because they're sort of debated heavily in life cycle assessment world, we've just made that net calculation voluntary rather than requiring it. So that puts us more in line with other life cycle assessment standards. So it certainly doesn't prevent anybody from making that net calculation, but it makes it an option rather than a requirement. We are maintaining the two types of assessment that that we had in the first draft. So you can do either of these or both of these for any given building. The projected assessment, again, we're tracking with how HERS ratings go. The projected assessment is done on the plan set. So, you've got a set of plans. It has specified the dimensions and the products that are going to be used. So you can do an embodied carbon assessment at that point in the building's lifespan. And then a confirmed assessment is leveraging the rater going to the site, already going to the site to confirm a bunch of things for a HERS rating. That same HERS rater can now do a confirmed assessment where they're looking at the products that are used in the building and confirming that those are indeed what went in there. Same kind of procedure if the HERS rater gets to the site and finds that a product is different than it was from the projected assessment, then that assessment is adjusted to reflect the GWP of the products that were actually installed in the building. So the projected assessment will sort of, help designers and builders understand what the carbon footprint of the building should look like, and sort of make any choices or refinements there. And the confirmed assessment will just, ensure that that is actually the case and make any corrections if things changed in practice on site. There's a whole table of verification procedures in the standard, and nothing has really changed about this, but again, we had some really helpful input on ways to sort of clarify and make it a little more straightforward for raters to sort of understand what's expected of them when they're doing a verification. So if you're looking at draft 2, you'll see quite a few really helpful additions to the verification procedures. So with the standard, moving closer to being adopted, I wanted to take a minute here to share a few next steps with you. Along with RESNET and myself at Home Builders Can, we are looking towards developing some pilot training and an embodied carbon study that would come out of that pilot training. So we're looking to lead a group of builders who are interested in being early adopters of 1550 to get trained on how to do the assessment. Whoop, I'm very sorry about that. To get trained on how to use the standard, to get some mentorship, so a little QA on the, on your first bunch of assessments, get to understand the time and cost of doing those assessments, and starting to, be among the early adopters to get the insights into what the embodied carbon hotspots might be, and being able to sort of pin down the affordable solutions for reducing embodied carbon. And so that will be kind of rolling out ideally over calendar year 2026 in 3 phases. So the first being the training. So we'll be working with RESNET and participants in sort of developing that pilot training and delivering it, and having folks actually, go through the training. That'll help us make sure that the training is good and on track, and get a bunch of leading builders working on doing those assessments. So phase 2, after you've learned how to use the standard, would be to have the project teams do a number of embodied carbon assessments for selected home designs in their portfolio, and then getting some oversight and sort of quality assurance on how those were done. And then our team at Home Builders Can will kind of take the anonymized data from those early participants and use it to do an embodied carbon study, a national embodied carbon study that will enable us to, kind of understand, how things look at from an industry-wide perspective, and come up with an embodied carbon playbook. So really mining that data to figure out, what is it that we can do collectively as an industry? What are the sort of go-to strategies for being able to reduce embodied carbon? And then, out the other side of having delivered all of that pilot training, we'll be able to refine that training program with all the lessons learned from the pilot. So if you have an interest in participating in that, feel free to reach out to me at Home Builders Can or the folks at RESNET, and we'll be sort of getting that underway early in 2026, hopefully. So with that, that's the end of the presentation. So we have some time now for questions if folks have on the standard in general, or the second draft in particular. Glad to take any questions you have now.
Great, thank you, Chris. We have a few. One from John Porterfield asking, have construction material firms given feedback to the standard development? He's impressed by the thoroughness of all this. He says he presented a comparison of a Chicago legacy 6-unit building rehabilitation with greater efficiency to modeled equivalent new construction, both embodied energy of materials and actual to modeled annual energy. The finding was 22 years to balance total energy use comparing rehab to demo and build build new, using embodied energy figures from Hannon et al., UI, UC, AC, EEE, 1983. So have you gotten any feedback from construction material firms?
Yeah, we've had, there's several manufacturers who are on the standard development committee. We have reps of even more manufacturers who've been in the technical working groups with us. So we've had their participation all the way through, and yeah, I mean most of the leading manufacturers these days have produced EPDs for their products, and that's really, you know, the main requirement slash ask of manufacturers as we get into measuring embodied carbon is, you know, those EPD documents are kind of the backbone of these calculations. So, you know, the more EPDs we have, the more accurately you can represent your building. But really what makes it possible to do 1550 right now is the fact that, you know, especially in the major product categories that go into a new home, the number of and the sort of the depth of EPD coverage has just grown, you know, really quickly over the last 5 years. And, you know, we can now be quite confident that you can find, you know, the majority of the specific brands of products that you would use in a home, but you can definitely find, you know, representative data for all the products that are included in the standard. And I'll just say, you know, that's a great call. I didn't include that here, but the standard does have some language around how to do this kind of assessment for a retrofit. And basically, we've followed the same procedures that other embodied carbon standards have done, which is to sort of say, if you're remodeling a home, the existing home, you kind of give it a 0 for its embodied carbon because, you know, those emissions went into the atmosphere. They're not sort of a result of any decisions being made during the retrofit. So you kind of start from an assumption that you're kind of at 0, and then you would do the same kind of assessment that you would do for new construction here, but you would only be including those products that are being replaced in the building. So if you're putting down new flooring and new cladding, those are the 2 product categories that you would do the embodied carbon assessment on. If you're doing, you know, roof, walls, you know, paint, whatever it happens to be, there are sort of procedures in 1550 for how to do that in a retrofit scenario.
Great. A sort of correlating question is from Lucas Johnson asking, are there elements like HVAC, appliance, water lines, et cetera, included in the process? Yeah,
so we did, one of the, I think the sort of jumps forward for this standard compared to how embodied carbon for homes has been done previously is that we do include MEP products. So that would be like all the HVAC, both the equipment and the distribution stuff, plumbing fixtures, and, you know, water lines and drain and vent lines, and electrical, you know, wiring boxes, panels, those sorts of things. Now the EPD data for those product categories is not great right now. So one of the things that we did in draft 1 was did a lot of research to develop a table of default values for all of those parts of the building. So by and large, you know, that's the one part of 1550 where we're not really expecting the users of the standard to be using product-specific EPDs because there aren't any. But our default tables, I think, are really complete and give good calculations for, you know, things like the anticipated amount of wiring per square foot of a home, you know, distribution pipes, plumbing pipes, all of those things. So, and that includes, you know, the HVAC equipment like heat pumps or furnaces, ventilation equipment. All of those things have default values built into the standard. So that will sort of enable us to, for people to kind of get some insights into the contributions of those elements of the building, and also encourage the manufacturers in those sectors to start producing EPDs as well.
Great. It looks like our last question is from Justin Krupa. Currently, there are recommended strategies or EPD databases to find GWP factors to apply to the minimum assessed product qualities in Table 10.1.1 that do not have defaults already provided for in Table 10.1.5, or is there a separate database of more default GWP factors that would be appropriate to use?
So I think that question is getting into the realm of software that will enable us to execute on 1550. So 1550 is kind of setting the rules, but it will be there will be some sort of software in between the user and the standard and it's in those software packages that those EPD databases will kind of be embedded. So, a lot like with the energy modeling, not many people are sort of wading through the RESNET standard to do their energy model. They're using a software that has all of the parameters of the standard embedded. It'll be the same with embodied carbon. So for one, I know that the BEAM tool that's I was involved in developing initially, I know that team is really working on developing a 1550 compliant version of their tool. So the actual EPD product databases will be something that you'll find in the software, and the standard, because those things change all the time, and softwares come and go and databases come and go. The standard won't be the place where all that data lives. It just sets the rules for what data you would include in one of those databases.
Great. With that, I don't see any additional questions. As you mentioned, they can reach out to us at RESNET or to you if they have some additional questions, and also, of course, to put in their comments by October 3rd. They can use the standards process page online on the RESNET website. Any last words before we close out, Chris?
I think just for folks who are thinking about making comments, it was really helpful, or I found it really helpful. I'm assuming I can speak for the rest of the committee, to hear positive comments, not just hey, we don't like this, or we think this part could be better. Those are obviously really helpful, because that really all those comments we got really helped up the confidence and the clarity of this section. But it is also really helpful to know, like, if we get a lot of people saying, hey, we think you did that right, that's really helpful to know too. So I would say, don't feel like if you're going to comment, you don't only have to propose changes. You can also sort of let us know what parts of the standard you're in support of as well. Those are helpful too. But please do comment. I guess that's how I'd wrap up. We have until the end of this week.
My apologies, because GoToWebinar was a little slow, and actually are quite a few questions left over. So let's see. Okay. Let's see. I think you addressed this briefly in the last answer about what softwares are expected to support this standard. This would be RESNET accredited software, I'm assuming. Yeah. So we had two software companies had reps in the technical committees. So that was Builders for Climate Action and BEAM, and I'm sorry, I'm blanking on the other one right now. It will come to me, and I'll mention it. But I would expect that those two will be offering something shortly after the standard comes out. I'm not sure if this is in the standard or not, but there's a question regarding whether or not there'll be required training for HERS raters and RFIs, and how it will be offered. Does the standard currently reference the training requirements? No, because this is my first RESNET standard, my understanding from the RESNET team is that we make the standard and then we'll make the training. Obviously, we can't finish a training program until we have a standard to base it on, but yeah, the idea, it'll follow similar to other RESNET standards, where you get trained and certified
in the use of a particular standard. In this case, it would be 1550, but yeah, that's what we'll sort of be rolling out over the sort of first half through, to the end of 2026 is that training and that certification.
Yes, of course. Another question, is the standard RESNET development compliant with ISO 14044, and will the standard meet the needs of GRESB reporting?
Yes, that's our intent. So all the sort of elements of life cycle assessment embedded in here are intended to follow, at least the minimum requirements of those ISO standards that look at life cycle assessment. So yes, that it should be compliant.
Okay. What is done for the products that are replaced multiple times during the life of the building?
So currently in this version of the standard, nothing. They're counted, once, and there's no sort of look at the cycle of replacement. And that was, definitely one of the thorny questions that we wrestled with. And it is one of the places where this kind of more residential focused standard is different than some of the LCA standards that are out there for commercial buildings, or being developed anyway for commercial buildings. Because, in commercial buildings, the owner tends to sort of be responsible for maintenance, replacement, all of those sorts of elements, and that's typically done at sort of scheduled times. And so there are a lot more, there's a lot more reliable information and sort of expectations around replacements in the commercial world than in the residential world. We know that in residential buildings, if your cladding is supposed to be replaced in 25 years, I mean, sometimes it's replaced the day somebody new buys the house because they like something else better. Sometimes it stays on the building, 3 times longer than it was supposed to because the person either likes it or can't afford to change it, and so on through all the elements of the building. So it was, we just found it challenging to the point of not being able to feel like we could give good, valid information on replacements. And so not that that's not important. We just didn't feel that we could do it in an accurate and actionable way for this standard. So this is a standard for measuring that first time impact of the home, but it's sort of right now not accounting for anything that happens down the road, whether it be the very first replacement of the very first thing that breaks, through to the actual end of the building's life. This standard is currently not commenting on any of that.
Great. Okay. Do you have a favorite way to estimate transportation emissions for a specific project, given that it's not included in the standard?
Yeah, that's another one that we wrestled with. When I first started doing this kind of life cycle assessment for residential buildings, one of the early barriers I hit was the lack of transparency when it comes to retail supply chains for residential construction. So in a lot of LCA standards, there are sort of assumptions made that, if your building site is here and the closest factory that makes that product is here, you're essentially just using that distance as a default for transportation. And I was curious to, explore that for residential buildings, and found that, that's often or almost always not the case, because it's very rare for a product to go from manufacturer directly to job site. There's a lot of logistics, warehousing, and moving around, and depending on the retailer and the way the supply chain is moving, a product, you might be living very close to a factory, but you may actually be getting a product that's made at a factory somewhere else that's been shipped to your local retailer for a variety of reasons. So that we just found that one, very, very difficult to peel apart. And then you also, in residential construction, have an awful lot of sort of last mile moving around of supplies, where the home builder needs, one more box of nails, or, one more this or that, and makes a run to the, a local retailer to go get that. So all around, we just found the complexity of doing the transportation emissions. We would have just been giving some pretty vague general numbers that wouldn't necessarily have been helpful. And so, in the absence of good information, we just decided to give no information. So I didn't really answer your question. Do I have a favorite way of doing that? I mean, to me, the only way you can really do that is to really do it, is to, track where you're getting things from, to try to track, what that looks like in the supply chain. You could simplify that by sort of, picking a factory, picking your retailer, and, trying to draw that loop. But it's honestly, it's a tricky one to untangle, and we just couldn't figure out how to do it. So I think if you want to do it, at the highest level, know where the things you're using are made, and try to select ones that are made closer to the construction site. But even that can be difficult to pin down sometimes. So I'm not sure there is a really great way to do that right now.
Okay, next one is there a draft checklist or calculator?
Well, like I said, there will be tools that come out to sort of provide the data and to kind of like do all the calculations inside. If you were a real keener and you wanted to do this by hand, you could find a free EPD database like the EC3 version that's out there, and you could go through and kind of try to do all of these calculations. I would suggest waiting until the standard is out. We just did I was involved in a presentation at EBA a couple weeks ago where we looked at EPDs. We had Sean Hunter from DuPont sort of showing their EPDs. There's a lot of calculations. If you don't know life cycle assessment and you're not really sure how to read an EPD, there's lots of places you could go wrong, because you might be looking at an EPD that says, this product has, I'll just throw out a number, 50 kilograms of emissions associated with 1 kilogram of the product. But then you have to know, like, how many kilograms of that product are you putting in your building? And so, all of those background calculations are the things that are going to get embedded into the software. That if you tried to just, wade your way through 1550, by hand, you'd want to make sure that you, really, really understood how all of those conversions work, and to make sure that, you're specifying the right amount of product in the right denominator to be able to get the emissions factors right.
Lastly, a follow-up regarding the software question. Before those softwares are released, does finding GWP factors look like visiting manufacturer websites and any pre-existing EPD databases directly? I think you addressed a little bit of that prior.
Yes, yeah, that's what it would be. Again, I think you'll find that that at least Beam is going to have a software that's works with 1550 quite shortly after the standard is released. So my take on it would be, even if you're really keen, maybe hold off until there's software, because it's a huge amount of work to try to do this without the help of a software program, but it's actually really quite straightforward and quite easy to do it with the software. So I guess that would be my advice is just hold off and wait for the software to come first.
Great. Well, that now appears to be the last of our questions. Thank you so much, Chris, for joining us today and providing all this valuable insight. Again, the comment period closes October 3rd. You all will be receiving an email shortly with a copy of Chris's slides and the audio recording, and with also a link to the standard for comments for those who are interested. Thank you again, Chris, for your time. Thanks everyone for joining us today, and have a great day.
Thanks. Bye.